Okay, so we're going to talk about integration by parts. I'm going to write the problem down. Feel free to pause the video as soon as I write the problem down, and you can try to do the problem yourself and then come back and see what I'm doing. Let's see, to integrate this by using parts. So one acronym that some people use is LIPIT. LIPIT stands for logs, inverse trig, polynomials, exponentials. I don't know why I wrote an extra E there for exponentials, and then trig. So that helps you pick which one should be your U. So since that's a polynomial and that's an exponential, I'll go ahead and make my x my U. So U is x, which means that du is dx. You could also write du dx as 1, and then write du equals dx. On the other side, I'll have dv, that's e to the negative x over 10 dx. And I have to think a little bit to get to v here, because the derivative of e to the stuff is e to the stuff times the derivative of the stuff. Well, to go backwards, I need to multiply by negative 10, because the derivative of e to the negative x over 10 is e to the negative x over 10 times negative 1/10. So when I multiply by negative 1/10, that 10 will go away and become a 1, like it is right there. So then my pattern for integration by parts, you integrate, I get uv minus the integral of v du, so this is u dv. If you don't know where that comes from, it comes from product rule. I'll go on a quick little tangent here. If I take the derivative of uv, so the derivative of uv, that's going to be du dx v plus u dv dx, which is, you can shorten things and write it as v du plus u dv, and that's ddx of uv. And then if you integrate both sides, this side just becomes uv, this side becomes integral v du plus integral u dv. And then if you solve for v du, you get what I have up here, uv minus the integral of v du. So we're just undoing product rule. So u v, so negative 10x e to the negative x over 10, minus the integral of v e to the negative x over 10, no, v, sorry, not dv, negative 10 e to the negative x over 10 du. So those negatives will cancel. So then I have negative 10x e to the negative x over 10 plus, well, this is e to the negative x over 10. Instead of 10, I want to put, not a plus, minus 100 plus c. Now I put a minus 100 because when I take the derivative of e to the negative x over 10, I'll have a negative 1/10 pop out, so that'll make this negative 100 become a 10. If that's not clear, just in case you need it, if you wanted to, take the derivative of what I have. So negative, I was deciding whether I should do an integral or a derivative. Take the derivative of this. The derivative of this is going to be negative 100 e to the negative x over 10 times negative 1/10. So negative 100 and negative 1/10 make 10, in case you're confused about that. Another problem. You might notice this is similar. Now, feel free to pause and try the problem yourself. It's going to be a very similar idea. So I'll say u is x squared, which means that du dx is 2x, and then multiply by dx, basically. And then dv is e to the negative x over 10 dx. So that means v is e to the negative x over 10 with a negative 10 in front. So uv minus the integral of v du. let's go ahead and simplify what I have. So I have negative 10x squared e to the negative x over 10 plus, that's going to be 20x e to the negative x over 10 dx. Now I could steal from my prior work, but I'm going to go ahead and show you. And I'm actually going to move that 20 in. So what I'm going to do is I'm going to make u 20x, which means that du is 20 dx, and then dv is e to the negative x over 10 dx, and v is e to the negative x over 10 with a negative 10 in front. So let's carry things down from the, and if you want to, you could call these u1 and v1 so you don't get confused. And let's carry down what we had. So we had negative 10x squared e to the negative x over 10. Now we're going to have uv. So uv is minus 200 x e to the negative x over 10 minus the integral of v du. And du actually has 20 dx. There we go. So let's rewrite this so we don't mess things up. X squared e to the negative x over 10 minus 200x e to the negative x over 10 plus 200 e to the negative x over 10 dx. So the underderivative of that last part is what I need. X squared e to the negative x over 10, 200 e to the negative x over 10. So that's going to be e to the negative x over 10. And I'm going to need to put a negative 10 in front. But since I already have a 200, 200 times negative 10 is negative 2,000 plus c. Okay, so I did the problem. Now, I could have done it using the table method. So using the table method, we had started with x squared e to the negative 10, x over 10, I keep writing 10, dx. In one column, we want u stuff. So u, and really it's helpful if that u stuff goes to 0, as that does. And on the other column, we start with our dv stuff. So we go underderivatives for that. So u stuff, we take derivatives. V stuff, we go underderivatives. So that's going to be negative 10. And then e to the negative x over 10, that's going to be 100. And then e to the negative x over 10, that's going to be negative 1,000. So now we just connect pieces. uv, negative 10x squared e to the x over 10. Notice it's there. And then that's uv, and then, so this is a plus here, and then a minus here, minus v du. So that's going to be 2 times 100, which is 20x, 200x, sorry, negative x over 10, which I have there. And then a minus minus, which is a plus. And then that's 2,000 e to the negative x over 10 plus c, which is there. And we matched. Beautiful. Our next problem. We've got x squared natural log of x dx. I would like my u to be the natural log because I don't know how to underderivative that. So my du is 1 over x dx. Or du dx is 1 over x, then multiply in parentheses, in quotes, by dx. And then my dv is x squared dx. So my v is 1/3 x cubed dx. Not dx. Just 1/3 x cubed. What are you doing? All right. So that gives me uv, 1/3 x cubed natural log of x, minus the integral of v du. So that's going to be 1/3 x cubed over x, which is x squared dx. And 1/3 x cubed, natural log of x. That's x squared, so that's going to be x cubed. We need a 1/3 in front. We already have a 1/3 in front, plus c. So we can go ahead and simplify that. 1/3 x cubed, natural log of x. 1/3 and 1/3 makes a 1/9, x cubed, plus c. We did that problem. Our next problem. X to the n, natural log of x, dx. They do state that n is an integer. So that means I can just do like power rule type of stuff. So this is similar to the problem we just did. U is going to be the natural log of x. Du is going to be 1 over x dx. dv is going to be x to the n dx, which means v is, okay, x to the n plus 1, compensate with 1 over n plus 1. So then we have uv, so that's going to be natural log of x, 1 over n plus 1, x to the n plus 1, minus the integral of v, n plus 1, x to the n plus 1, du times 1 over x dx. Ooh, that looks scary, that second piece, but let's take a look at it. So we have the natural log of x over n plus 1 times x to the n plus 1, minus the integral of x to the n plus 1 over x times n plus 1. Now I rewrote it, and I rewrote it on purpose, because that's x to the 1, and if I use my properties of exponents, then I can simplify that. N plus 1, x to the n plus 1. So that's just going to be x to the n over n plus 1 dx. Now that n plus 1 is just a coefficient. It just hangs out there. So I'll have natural log of x, n plus 1, x to the n plus 1. Underivative x to the n, that's x to the n plus 1 over n plus 1. But wait, I already have an n plus 1, plus c. So I could rewrite that if I so choose to x to the n plus 1 over n plus 1 squared plus c. Now we just have to consider, okay, so n was all integers, but what if, so it's x to the n natural log of x. What if we have a -1 there? So that would mean my u is the natural log of x, my du is 1 over x dx, my dv is x to the -1 dx, and my v is natural log of x. So then I would have natural log of x squared, because that's uv, minus the integral of v, natural log of x, du over x dx. So now, and then we have to integrate that natural log of x over x. So that's going to be, u is going to be natural log of x, and du, we're going to do substitution, dx is 1 over x, so du dx is x du. So we're going to have the natural log of x squared minus the integral of u over x, x du. Notice that these x's cancel. So then we underivative the u, so that's going to be natural log of x squared minus 1/2 u squared plus c, which is natural log of x squared minus 1/2 natural log of x squared plus c, which we could combine those if we wanted to. But I think that's probably the only other situation I would consider would be, what if happens if n is 0? Because then you just have the integral of the natural log of x dx, which you'd have to do parts for that also. I'll do that one too, just for fun. So that's where u is going to be the natural log of x, du is going to be 1 over x dx, dv is dx, and therefore v is x. So it's going to be uv, natural log of x, times x, minus the integral of v du. Oh, my cat is rubbing on the iPad. So that's just 1 there. So that's x natural log of x minus, so that integral is just the integral of 1 dx. So that's just going to be x plus c. And I think that covers all special situations. What do we have? Okay, this is going to be our last problem. We have x squared sine x dx. So let's go ahead and make u x squared. I like picking u's that go to 0 if I can. And then dv is the sine of x dx, which means that v is the cosine, but wait, it's the negative cosine. So I have uv, negative x squared cosine x, minus the integral of v du. And looks like I'm going to need to do this again. So negative x squared cosine x plus 2x cosine x dx. Let's go ahead and make u x and du dx. Let's make dv cosine x dx and make v sine x. You don't need those ones, but I'm putting those ones simply to differentiate it from what I was talking about before. So I have what I started with. Oh, I forgot that 2. Let's put that 2 here just so I don't forget it. Plus uv minus the integral of v du. Oh, sine x, I can do that. So that's just going to be negative x squared cosine x, 2x sine x, and then 2, it's going to be a cosine x, but wait, negative, plus c. And we have finished. Now, we could have done this as a tabular one again, so let's show that. We had x squared sine x to begin. So my u was x squared. If you're hearing random sounds, that would be my cat in the background wandering around. X squared, 2x, 2, 0, taking the derivative of u stuff. And then sine x, that's v stuff, so dv, so underderivative of that. Negative cosine, negative sine, and then cosine. And let's combine these pieces and hope that we get the same thing. uv, negative x squared cosine x, minus the integral, so minus negative 2x sine x, and then minus minus, so plus 2 oh look, it's the same thing we had. You don't have to do both techniques, you just need one.